Okay. Um, Drop the link to the Discord in the comments. All right. And so we begin again. Okay, so I had this little realization thinking about, having done this. I'm not sure if I counted right, but maybe the 10th time now. What's the process here? So what if we were to write a little shell command for the process? Well, in the effect that we've got, okay, go, Alice, go join the meeting, start OBS, stream to YouTube, grab the active link, run it through a shortener to basically add like a latest tag on it, like almost like a container image. I wonder if we could use the registries. The registries just have such good support. They have the built-in capabilities of scanning. Um, uh, I wonder if we could use. Well, no, we don't want to do that. We're doing that. We're doing this. Okay. So we're okay. So yeah. So URL shortener live. So basically, the URL shortener dot whatever slash live should be whatever the active stream link is, and then basically tweet the, or actually no, we don't want to do that. We don't need. Okay, so yeah, okay, I don't know. I guess we don't really need that slash live. I guess that was really if we were going to. That was really only if we were going to not have this and then just have the URL shortener. So originally, I think I wrote a thing that was for the URL shortener, but then it turned into this, which is basically more of the stream approach. Okay, so basically, what was interesting about this? So in the process of doing this, um, it occurred to me that we already have a rudimentary parser for shell commands in the console test plugin, Sphinx extension, which is in the DFML util testing console test. Um, and there's video on that one. If you go to the README, it's there. And so um, this would allow to, okay, so basically, one of the things in the map for the introduction and context is if you look at the to-dos, let's see, I think we're right here. Actually, yeah, so where is the to-dos? Okay, where's the to-dos? Uh, okay, here. Yeah, what is this? Okay, so this is chapter one. Okay, so yeah, and so we're doing, so basically I put the stuff in chapter one, but basically we're filtering this stuff into chapter zero when it's core library stuff, right? And because core library stuff, we're treating chapter one as first use case, right? First deployment of Alice, right? And chapter zero is sort of like, okay, we got all the foundations there, right? That's why we're focused on the DIDs right now. Which is we're basically going to put links to all the data in our input networks, which is where our data flows get their data on the blockchain, so that you can kind of communicate easily across different protocols. So basically, um, yeah. So we're working on this Alice on chain. That's why the server's on the chain. And then we're going to do the data flows class. And so what we did is we found this PureDID spec. We determined that the implementation that we found the spec off of, and we've determined that PureDIDs are indeed what we want. They're basically these, sort of graph network, graph, a graph of, it's basically, think of it like, you're combining like TCP and GPG or something, right? Like you have the ability to encode for different parties, and you also have this notion of like, streams of data. I think, and at least the ability for this synchronous or asynchronous communication, to sort of just send receive one packet at a time, or whole stream. So I believe that's what the point is. Now, so this looks ideal for us, right? So then we can choose our transport layer underneath. And what we want to do though is this implementation that we found the spec off of there's 3 layers, and this only supports layer 2 and 1 and 2. So we want to go see if there's a layer 3 implementation available. And these Hyperledger Aries RFCs. So this looks pretty active, and I think I saw another thing, but it didn't look up to date. So I'm wondering if we should just go and look at some of this Aries stuff. This looks to be pretty active. Secure storage. System for data flows. Okay, so this sounds similar to what DFML is doing, but with Go. Oh, this is great. Central orchestration, plugin interface, microservice collection. Okay. Hmm. Okay. Samples. Okay, what have they got? Private data transfer CLI and UI. What is this CLI? Okay, so run the application. You will require a two-party Firefly system running locally on ports blank per blank. The easiest way to set that up is with Firefly CLI. Okay, once the Firefly stack is set up, and run the sample with npm init npm install. Okay, so this is the one concern that I have off the bat, is that um, okay, so I'm trying to figure out how does this get run. So they start these things, and then so they're listening on ports, and um, they're listening on ports, and they're talking over WebSockets. This is one layer too high for us in a level of abstraction stack. Um, so we want to be HTTPS data exchange, Fabric connector, performance UI. Okay. MTLS data exchange to organizations. Okay, so this is going to sync across, but once again, they're doing this thing where they are create config.json. Okay. Set up org B. Okay, so this is syncing across 2 orgs. Okay, so this is good. This is good stuff. This one looks like we can use this. Um, So we're gonna drop the link in here. All right, so then found out, so I found out that um, uh, Hyperledger has Firefly project similar to DFFML, but in Go, no ML that we can see so far. Um, so maybe we would fit under Hyperledger. Maybe we could go into the Hyperledger Foundation if there's a gap here with this ML built upon Firefly. Maybe we could be something that builds upon Firefly. Okay. Plugin for collector. Okay, so you have to write the plugins in Go. Okay, connector. Run skills independent from. Okay. So Firefly plugin architecture. Are we streaming still? Okay, we are. Great. So Firefly plugin architecture. All right, so we've identified the fact that yet another layer in the abstraction stack has been built on top of what we thought was the state of the art. So it's Firefly. Okay, so this Firefly thing, it looks like it uses peer DIDs underneath. Probably is my guess. So basically, they're just gonna they have this blockchain, and this blockchain involves some data flow stuff. So it might be a it might be something that we need to investigate further because they were using this pure DID stuff. So if it's built on top of that, that gives us interoperability with the rest of their ecosystem, which is very powerful. So differences in architecture's design, separation. Okay, so you can write in a different language. Okay, so this is great. So we could definitely leverage this. Okay, so we want to throw plugins. Okay, Ethernet client code, Fabric connect client to blockchain interface. And Go is great because Go cross compiles to different platforms, so that's great. On-chain identity. Okay, IPFS. So IPFS server, HTTP WebSocket, external microservices, Firefly Data Exchange, HTTPS client. Service connectors. Okay, so here's the connectors. Infrastructure runtimes, plugins. Okay, it's multi-party event sequencing. This looks good so far. Event stream, perfect. IPFS messaging, DB, blob store, that's perfect. Private file transfer. Okay, so so IPFS though, I really want it to be able to go over more than just IPFS. Um, we need this to work over more than just that because we want to leverage Kubernetes for the execution environment on this one, which means that we need to work over like a um, uh, Kubernetes-based messaging system. So how do we integrate Firefly with Kubernetes? So I wonder if anybody has done that. So somebody's integrated Firefly over Kubernetes. Then we can just throw our ML jobs on top of that. Okay, so integrated them properly though. Okay, so let's maybe go to the Hyperledger Foundation and just see what projects they've got going on because I guess now I'm realizing it's been a few years since I looked at their stuff. So maybe, and this is new to me, so I thought I knew what they had, but I don't. So let's see. So Aries. Okay, so this Aries I think is what we found referencing it. Standard interface. Okay, great. Hyperledger transact. Okay, so we can encode to this Hyperledger transact. We should be interoperable with this. So data flow should be interoperable with Hyperledger transact. Okay. So Hyperledger Transact is a platform-agnostic library for executing transactions with smart contracts. The Hyperledger Transact project consists of several repositories. This contains the Transact Rust library. The Transact Concept library contains examples and reference implementations. And then there's RFCs. So let's go check out the RFCs so we can understand what's the state of the art. SQL-backed Merkle state. That's cool. Okay. Add state trace. Okay, we need to get cross-check sync or transactions. Okay. So if we can use this stuff to trigger the operations that are running within the Kubernetes cluster. So basically, new versions of the state tree. Okay, so transact. What else is these people working on? So this would maybe hint to us if there's something more state of the art here. Okay, this just looks like, hey, so they're a contracting company. Okay, so maybe we need to connect with whoever is in Intel and talk to them to see, well, I'm already talking to Marcel, so we'll get her. Okay, so talk to Marcel. Talk to Marcella about Hyperledger, because she said she's involved in this stuff. Transact, and if there is any K8 integration, she knows about planned. So my understanding is that of how these things works is like when you have something like the Hyperledger Foundation or these foundations, basically the companies will get together and say, hey, we'd like to see some kind of interoperability happen between our companies. And then they form these foundations, and the foundation then pays the contractors, and the contractors, the contract for hire, the guys and gals and everybody, um, they go and they go and write whatever these projects are, and in this case, see, they're based around these shared specs that are being shared in the Hyperledger community and other places. So So it looks like the DID specs are really, yeah, the foundation of it all. And then this Hyperledger stuff is really putting it into a usable blockchain for us, and giving us interoperability with the rest of the Hyperledger ecosystem. So what we're going to do is at the end of this, we'll have knitted, I think there was an Onyx project up there, but we'll have knitted the unified, Onyx models with Hyperledger. Maybe we should just Google for that, just make sure nobody else has done it. Okay. Privacy. Okay, so privacy preserving transparent supply chain management through Hyperledger Fabric. Um, this sounds like what we're interested in. Yeah, we want to use it for our software supply chain. Um, so we're gonna apply this paper to our software API, our software supply chain. So, but this is based on top of Fabric. We want to implement. Okay, so basically, let's take this. Let's go implement this based off of. Um, so here's our. We're gonna go uh, supply chain implemented on Fabric, privacy preserving. Implemented on Fabric. Uh, extend and uh, uh, translate to transact to leverage new Web3 concepts such as DIDs off the bat. And I know there's grafting and whatever, but let's just try to use those stuff. And it's already written in Rust. Remember, we said we wanted to use things written in Rust. So, okay, so 16 days ago, state traits. Okay, I like that they're looking at states. I mean, we know that that's fantastic, right? We know everything is state in some way, right? We have to manage it somehow. So they're looking at state. Even if it's stateless, it's either on or off. So, and that's recent, so that's good. So, okay. So this is Twitter. We don't need Twitter. Okay, so Hyperledger Transact is a platform agnostic library. Okay, so reference implementations. Okay, so what else are these people working on? Okay, here's the wiki on Transact. Okay, so we're going to note that yes, the best practices is not all the way there, but that's okay. This is experimental stuff we're doing. We accept that. So project management. Let's go check out their sign in with GitHub. So let's go check out their roadmap and see if this is something that we can depend on. Okay, I have no idea. And no, I don't want to, no, make it go away. Okay. Ah, okay. Okay, so man, if we could do something with this, I would be very excited. So just make sure that we can use our own, we might implement zero MQ execution adapter, prove correctness of serial scheduler, write multi-database RFC for transact, in review. Okay, yeah, so that's in review. Implement lock-free context manager. What is that? Implement lock-free context manager that is readable from multiple threads. Okay, so this is in Rust. So Epic Link parity with Sawtooth. Okay, so they are trying to, yeah, so they are trying to build this thing on top of these new Web3 specs. So basically, it looks like so the Hyperledger Foundation has for the past few years been building blockchain stuff, and they've built more and more blockchain projects, and they sort of figure out different things as they build them through these contractors that build them and the community that engages with them via the corporations that are funding it, and then elsewhere. But generally the contractors lead the engagement there. And I wonder how that maps to the team topology stuff. So we'll have to figure out and map that to the team topology stuff. So to understand better, what is happening here as far as when we need to build these strategic plan models that will uh, show Alice how to navigate with different agents working in different areas with different models trained to be good at different things or different assets that allow them to validate certain system contexts, right? When we're building this giant distributed network of compute, right? And where it's not just it's not software developers, right? But if Alice is the software developer and it's other copies of her, and they're all doing software development with their different resources being the different computer or whatever they're attached to, then you're creating this giant network of things that work together, right? And so yeah, we want that to be on top of the DID stuff. Now I can't remember how we got there. Okay. Oh yeah, and so the blockchain is good because it's all about interoperability. The blockchain is that highway for the data, or like the train, whatever. Okay, so it looks like, here's what we know. So it looks like they support this interface for plugins. We have a question mark around can we make that interface for plugins connect to our, arbitrary DFML ecosystem of plugin stuff, right? And I think our next order of business is we've confirmed this uses DIDs, probably offers support to the most complete level that anybody's going to be offering right now. We need to go look for projects that might be using Transact. Um, dependence. Okay, so it looks like Saber, Scabbard. Scabbard uses two-phase consensus to reach agreement on transactions. Scabbard is okay. So let's check out these things. So these are dependencies, and these are um, on-chain smart contracts. Okay, let's go check this out. There's no search. Okay, I'm not seeing it. So what is this Scabbard SDK? 5 months ago, 15 versions, dependence, transact. Are these, they depend on each other? Okay. Okay, yeah. And so what is this grid? So this grid was their thing that was all about supply chain. That's right. So built-in support for industry standards, open source for flexibility, Sawtooth or Splinter. So what is Splinter? Privacy-focused platform to distribute blockchain-inspired network environment for private communication and transactions between organizations. Okay, Grid. Use Splinter as a backend for Grid. Okay, so grid uses. Okay, so what are we doing? So wait a minute. So we got too far down. So where was that one? Where's that one? So Hyperledger supply chain. Okay, so wow, we're back here. God, this is what I was trying to do like 2 years ago, and I didn't realize what we were doing at the time. I thought this was just like a secondary use case, and now it seems like it's the primary use case for at least what should be an input network. Um, because if every of all the data goes on the blockchain, then really all we need to focus about we really need to focus on supporting the blockchain as the data source, and then just do import export to that. So this needs to be right front and center. So let's just take this and say supply chain Hyperledger. So we are going to engage with the Hyperledger, whatever the supply chain people are, and we're going to try to figure out how to cross the open SSF supply chain work that's happening, supply chain security work that's happening with the Hyperledger supply chain security work, and we're going to add in, our machine learning on top. So we probably need to get involved in this Hyperledger supply chain SIG in some way, either as like a downstream user of one of the things that they're producing or an active participant. So depending on how deep we go here, because we really need to make sure that these things cross and support the software use case. So, okay. Okay, so great. So we're going to use, and this is really perfect because the blockchain and the distributed identifiers. So this is perfect. So this is critical. This is critical because blockchains and DIDs most accurately, most blockchains and DIDs uh, uh, easily translate into our open source ecosystems, open source ecosystem as a whole being a polyrepo development environment. Okay, so think grafting equals forks, and then communications blockchain, uh, and then this is like central comms. Okay, and this is like okay, so where do I find the chat server? Is the chat server blockchain based? Maybe, right? Maybe it is. Who's to say? Um, so so we're gonna build on this thing. So what was that thing that they have? Is it grid? Was it grid? Okay, so what else is going on in this space? What is this? Aha, these people are doing the same thing we are. Yeah, exactly. This is exactly what we're trying to do. Yep, yep, bingo. Bingo. This is exactly what we're trying to do. Yeah, good description. All right, okay, well, welcome, MDX Blocks. You have a open source friend in the game here. So I wonder if they're all just like that. Um, okay, so are all of these people? So are these people doing anything open source? It doesn't look like it. And security. Yeah, so yeah, exactly. So, but it's not open source. All right, so in that case, potentially, um, yeah, well, I mean, they could potentially leverage what we do because we're going to do it, right? So, uh, if they wanted to, then they could do that, right? But this is very similar to exactly what we're talking about, right? We want to integrate across all of this, right? And allow you to deploy anything, anywhere, with whatever you want, with whatever configuration, right? And so the thing that we're adding on top of this is also like the end user interaction of that is the same thing, right? And then, the end user and the what is it's not just like integrating these things as they exist, but also like the communication between them all becomes this execution environment. Um, and that would be like one of these smart contract executors, right? I believe is what we're looking at. And so now we're going to look into like basically how do we map how are we mapping all the config in there. So we need to look at the executors for um, what is this? So yeah. So is this grid that we were looking at? Yeah, I think grid. Distributed ledgers. Okay, domain specific. Okay, so let's make sure we grab the supply chain one. Okay, so we have this grid. Okay, so grid and nearly allows cactus. Okay, so you can then integrate across. So, okay, so uh, so there's this yeah, so this Hyperledger Cactus blockchain integration to securely integrate different blockchains. Pluggable architecture enables execution of letter of multiple blockchain letters. Okay, so, and what is this? So, when was this? May 2020. Okay, so we better go check out this Cactus thing because this is a while ago. Um, what is the latest news? Okay, here we go. DIDs. We should have gone here to begin with. Lesson learned. Go to the foundation. Ho ho ho. Let's insert develop with the Indie DB. community. Affinity Bedrock ID units by any verifier. It's because objects are in the verifiable presentation reference the Hyperledger Indy network issued by their user. Their Indy DID method laid the groundwork to make this possible. This advancement in interoperability is significant while issuers still need to be anchored in the specific Indy ledger of their choice. Holders can seamlessly receive verified credentials from issuers rooted in different Hyperledger Indy networks, be able to create verifiable presentations from any combinations of those credentials. Likewise, verifiers will be able to verify presentations that include claims derived from credentials looted in multiple Indy networks. The Indy DID method paves the way for Hyperledger Indy credentials to scale by allowing Indy networks to seamlessly interoperate with a global network of networks effect. With this groundwork complete, agents and agent frameworks need to interoperate with the Indy DID method. This community adoption will increase the ability of Indies in Aries stack. So Aries is the other one we were interested in, and position it to be a globally dominant way to issue shared verifiable credentials in a multi-ledger world. So this is perfect. Okay, so May 5th. So that just happened. So we're finally up to date. So we just got up to date. Yay, we're up to date. We're up to date. So this is it. Um, look at this. Look at this. Star. We're the first one to star this. All right. Okay. Okay. This is fantastic. This is fantastic. This is fantastic. This is fantastic. Okay. So, um, where is it? Where is it? Where is it? Okay. That means we found the edge. We found the edge of the train of thought. We found the edge. We found the edge of the train of thought. Okay. So basically, we found this looks like the state of the art. I think this is the state of the art. Who's this? Daniel. What are you doing? Aries Cloud Agent Python, updated 2 days ago. Decentralized non-mobile environments. Second and third layers. Just arrive. Okay, so Hyperledger Aries Cloud Agent Python is a foundation for building verifiable credential ecosystems. It operates on the second and third layers of the Trust over IP framework and DID comp. So this guy, he wrote this thing, wrote the blog post, put out the thing, and then the next thing we know, so what's he working on after he did that? He's immediately working on this Aries Python Cloud Agent, right? Which is, and where were we before? So he wrote this demo, and this demo was lauded as the thing that's going to be the most interoperable, right? And then where are we going from there? Well, we're going to this Aries Cloud Agent Python, which is this project. So this is this Aries thing which we saw before. It looks like, yes, it's looking at okay, so this looks like it's got, okay, so this works across mobile, so this gives us our communication across mobile. There we go. So React Native, Zondervan, all Aries repositories. Okay, this is great. So let's go check out the rest of the Aries repositories. Secure storage, mediator. What's mediator? Yeah, Caddy's great. Um, love Caddy. What is this? What is this mediator agency? Mediators and relays. Oh, hey, this guy again. Mental model of agent-to-agent messaging includes two important communication criminals. Mediator is a participant. Okay, so this is like the DWNs. Okay. Relay. DID com. Mediator. Okay, so mediator is their word for the mediator. Okay. Okay. What is this? Mediator is, oh, this is exciting. I didn't realize how far they'd made it. This is fantastic. This really is putting us in a very good position here. Okay, we can basically close out of grid. We can assume, so grid is the de facto Hyperledger supply chain solution, right? So basically, if we put all our software in a supply chain that grid can, we can basically, so we looked at the grafting stuff. That's basically where you take, a DID in one chain and put it on another chain, right? God, I've been really wanting to get into this stuff for years, and I never got the chance. But now's a good time. So, so it's basically going to get, I think my understanding is that it's going to graph these nodes basically between networks by copying their contents and reissuing with new keys or something like that. So um, the blog post we found, which was the most recent blog post from the Hyperledger Foundation, said that there was this state-of-the-art um, um, like there's this thing that's basically going to make, kind of like KCP, you can span across multiple clusters. This thing was saying for a Hyperledger, this is going to let us span across multiple basically clusters, being the chains in this case. So okay, so transact contract. Okay, yeah. And so we basically confirmed that here's this Aries stuff is using. So this Firefly was, how does this relate to this stuff? Blockchain plugin, on-chain, off-chain orchestration engine. Okay, yeah, that's where we plug in. That's what we want, the on-chain, off-chain orchestration engine. Data orchestration engine. Okay, where's the data orchestration engine? Okay, so data orchestration engine. Where would that be? Okay. So, okay, great. This takes care of the rest of it. So we just want to plug into the orchestration engine and then feed the data to the machine learning. Um, so Firefly, we're thinking that we can now take Firefly, um, and make it use a Aries I think we can have it use this Aries or transact. So Firefly using Aries or transact where we plug into their orchestrator concept. Okay, Firefly using Aries or Transact where we plug into their orchestrator concept. Okay, and then can leverage uh, uh, chain to chain network interoperability eminent due to better recent tooling to connect us to Hyperledger supply chain solution grid, which does not yet look to support look as if it supports DID-based chains directly. So basically, if we were going to go roll this out immediately, otherwise, so should probably look at roadmap first to see if time it takes to implement. Because anything where you're hosting stuff, I mean, you don't want to be hosting proxies more than you need to. You don't want to be hosting anything more than you need to. That's what this is going to tell us. Should probably look at roadmap first to see if time takes to implement uh, uh, grafting slash proxies slash multi network infra setup in parallel is comparable to their roadmap for direct support of DID-based chains. Okay, so basically, yeah. Okay, so great. So this is what we're thinking right now, is that basically we should plug into this Firefly orchestration engine to understand, how to execute our manifests. So let's see, unless they provide something that's zippity-doo-dah, in which case we'll just throw the ML on top of it. And if that already exists, then we'll just use it and we'll call it done. So Firefly. Okay, so how do we use it? Understanding it. Introduction to supernodes. What is a supernode? Okay, over the last decade, enterprise blockchain projects, architects, and developers have realized that they much more need than the blockchain node for their projects, that they need much more than a blockchain node for their projects to be successful. The development stack needed for enterprise-grade Web3 applications just as sophisticated as the stack required for Web2 applications as came before. A raw blockchain node is simply not enough. So your choice as a development team for a blockchain project becomes whether to build and update all the plumbing middleware components underneath. Okay, so this is like the DFFML of blockchain is what I'm seeing here. Yeah, this is like the DFFML of blockchain. This is great. Okay, so private data exchange press might be okay. Message queue, other way P2P gateway logic. So they support um, data exchange HTTPS. Okay, so they support. So this is critical. they support, see, you get so used to writing code that sometimes you forget that somebody's already written all of the code and you can just go use it. So it's important to go understand. So, so can implement data transfer over input network because data exchange supports transfer over arbitrary protocols mechanisms. Okay. Deterministic compute. This gets into human workflows. Yep. Okay, cool. Braces that. Okay. Okay, mixture of messaging. All right. Okay, great. Getting started. Okay, so great. They have this whole thing. Install the Firefly CLI. Okay, so you can basically, they have these containers set up and the containers will do their thing. And they're basically the super nodes and they'll be your backbone of communication. Um, use the sandbox. Okay, so the sandbox sits logically outside the supernode, acts like an end user application written to use Firefly's API. In your setup, you will have one sandbox per member, each taking their own Firefly API. The purpose of the sandbox is to provide quick and easy way to try out all the fundamental blocks that Firefly provides. It also shows developers through example code snippets how they would implement the same functionality in their own apps backend. So I think we're going to start to get into the identity aware context issue stuff here. And this is one of the things that I found with all these blockchain things a few years ago was that you'd go in and then like all of the demo applications are written without any instruction as to like how to set up more than one user. Like it's like when there used to be all of the WebRTC, like if you go to all these WebRTC demos, they're all pretty much set up to be like single user web pages, except for the ones that use Google's Stunner Turn server, and it's a little bit confusing. And so the same thing with these. But that lends itself, it's easier to understand. This stuff is a little bit hard to understand how you're supposed to do all these issuance workflows off the different types of things, but hopefully it's fixed now. So the purpose of the sandbox is to provide a quick and easy way to try out all the fundamental building blocks, technical details. It's a full stack web app, TypeScript, okay, Node.js. The Explorer, okay, you can see the transactions, that's great. Okay, sandbox, server code. Okay, things to try out. Okay, so you can basically load this thing up and you can broadcast messages. Okay, so contracts. Working with custom smart contracts. Okay, enables example smart contract, simple storage. Okay, it's going to execute. Okay, stack at least two members in an Ethereum blockchain. Okay, so we want to figure out how do we do a okay, Firefly interface, contract interface, Firefly FFI. Okay, great. So this is like a manifest that they're saying. They're telling us about a manifest basically. So this is their contract interface. And so list of methods, list of all events. Okay, this is a data flow. This is a data flow with a yeah, it's a data flow with a manifest. So we need to work with these people. If you find an Ethereum API for an existing, it should be applied on. Okay, so basically they have this mapping where they can figure out. They have this. Uh, okay, so more page. So Firefly. Okay, so let's go look at the other Firefly stuff. Automated generation of Firefly interfaces. Okay, so Firefly, we'll make a note here that says basically, um, Firefly looks like data flow slash manifest. Okay. Firefly Data Exchange HTTPS. So MTLS Data Exchange. Okay, so I think, what do we have here? So Nodemon. Good people. What are the open issues? Prometheus instrumentation. Okay, so we're gonna, hook this we're basically gonna do all. Okay, wait a minute. When is this thing last updated? Okay. Oh, they did a 1.0 11 days ago. Okay, so perfect. They just did a 1.0. Timing is good. So that's good. That means that this thing is recent. Are we streaming? I think we're, yeah, sometimes I get nervous. We lost something and I've been talking for no reason. Okay, we are. Okay. All right, so this is good. All right, so we may have found the state, the edge, the leaf. I remember we keep talking about trying to find this leaf node in the train of thought, right? So I'm curious, what is this Aries Cloud Agent Python, decentralized identity applications in non-mobile environments? This seems like something that would help us here. And then you have these things which, so what is this Aries Cloud Agent? Yeah, versus Indy. So Aries is the agent client, part of a decentralized identity ledger DID verifiable credentials application that is intended to be agnostic to the underlying ledger DIDs verifiable. Indy is a decentralized identity implementation, including support for a ledger. Initials Aries work was to move the agent work from Indy to Aries. So as first working versions of Aries use Indy underneath for the decentralized identity components. Over time, those components will become pluggable. And okay, so so basically we're going to Aries. Always looking at Aries to start. Okay, so let's look at Aries versus Fly. What is this called? Firefly. Three weeks ago. Let's just watch this video.
NFTs plus Amazon, and you get.
Oh. Make it stop.
was a Wouldn't it be nice if there was a platform or a technology stack that handles this for you? Wouldn't it be even better if it was open source and run by one of the leading communities out there through the Linux Foundation? Well, good news, there is, and that's what Firefly really does, and what the community is really excited about and the purpose of it. It handles out of the box support for multiple different protocols and chains. It has native support for things like tokens and digital assets. It's very pluggable, so you can bring your own wallet, custody, key management solutions. It also has out of the box off-chain technologies as well. So depending on your approach to data privacy, you have options. It has a robust orchestration layer, so things like reliable event delivery, retries on transaction submission, and so on are there. And it has a rich data layer as well out of the box. So a caching layer, a place to aggregate your private data.
To build our own private permission variant. And we learned a lot from that process too about some of the pluses that the industry wants in terms of privacy, security, what they felt comfortable with in terms of information being stored on different systems and that type of thing. And it was interesting because around 2022, we learned more about Kaleido and your work related to 2021 Firefly. And prior to that, we had been building our various versions of private permission to enterprise blockchain on our own. And what we learned was a lot.
I think it's pretty exciting to see these token-based models being used in an enterprise setting and solving some really challenging projects about some challenging issues projects have run into as they're trying to get this new type of collaboration.
Definitely is a message that resonates. That transparency aspect, the community aspect, are things that Synaptic was built upon from the beginning, as well. And then so saying, hey, we're going to work with this open source, so there's not that fear of vendor lock-in. And then also, for our ability to deliver, we have to be very focused on a narrow use case.
My name is Nico Geyer. I am a maintainer on the Hyperledger Firefly project and also the open source community lead. I'm super excited to show you Firefly in action.
Okay. Where did that YouTube video go? It sounds like it's playing something else. Okay. So this Firefly looks great. So we want to hook into this. So if we save these things as DIDs, we can leverage this Firefly stuff. So for our distributed network of communication later, right? Yeah, so we can leverage, so we'll just save everything as these DIDs, and then we can use the Firefly stuff later. So focus right now, because we've determined that we have interoperability. Okay, so we have determined that if we use DIDs, we'll have integration out of the box, integration with Hyperledger's Firefly, and Grid Solutions. Okay, so we know, what do we know? Okay, so we know we would like to understand the format of the data. So we would like to understand the format of the data as it exists within the a DID/DID doc, because I'm not sure what the difference is right now. We would like to understand the format of the data as it exists in a DID doc on one of those chains. We want to do this because we want to basically we want to take the data, we want to take the cold storage of the chain, all the DIDs, and be able to save/load that into input objects via operations calling input network context dot add after being run on data flow context, data flow as class, context entry, so as to watch chain for new inputs and filter for ones applicable for running context. Okay. So, okay, great. So it looks like they have this rich ecosystem. We're going to go encode our inputs into this network format, right? And so we're going to go just deploy it and then dump it to see how it is. This is just sort of, you know, just go deploy it and dump it. We just want an example of the data. We want a corpus of the data, right? And then if we can dump it, if we can dump the data from one of these DID-based networks, right? And basically, like maybe think of it like maybe it stores it in a database, and then we can dump the MySQL database or something, and then we can dump each record out of there. Then we can inspect each record and understand how it maps to this demo here, this demo that we'd been looking at from the peer ID. Spec, so that we can use the peer ID library to build these DIDs, and then we'll try to build DIDs which match the format of the ones that we dumped from the chain. And once we've done that, then we'll attempt to once we've done that, once we've done this thing where we generate new data that's in the format of the chain, we'll import it. We'll just generate it using this example code here. We'll import it. We should write this down as the plan. Okay. Plan. spin up DID chain using Firefly. DID based chain. So spin up a DID based chain using Firefly. Dump to cold storage. Inspect file format of inspect all records in chain. Understand how they map to records as they exist within UI, Firefly UI. Explorer. I think they usually call these things chain explorers. Understand how they map to records as they exist within the Firefly Explorer UI. So inspect all records in chain. Understand how each record maps to what is seen or unseen in the Firefly Explorer UI. Okay, so then, so basically we spin up the DID based chain using Firefly. We, dump example. So they usually have examples. They'll usually walk us through an example of like, here's how you set up our application, yada, 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 right? So we're basically just going to set it up and then dump it. And we're going to say, what does it look like? So, basically a file, not memory. Cold storage is just not memory. Inspect all records in chain. So, view the file. And this is just your basic, like, this is the basic stuff that you'd be doing if you were reverse engineering something, right? What's the protocol? What does it look like? What bits go where? Okay, understand each record maps to what is seen or unseen in the Firefly Explorer UI. Or understand how. Okay. So if we do that, then we'll know what we're doing, right? Okay, so attempt to generate inputs using execution of data flow. Then matching with values, matching what exists in data and metadata stored on chain in examples from Firefly example. Chain data. Write function, write operation, which runs on output, which grabs all inputs within input network and serializes them to the format that the example is in, the dumped example is in. Okay, so now if we're looking at this like we're creating our fuzzer, which in a way we're creating like this fuzzer that's going to build code as well as test code, because that's what Alice is going to do when she's debugging. This is like basically, the analysis of the corpus of our data, right? From looking at this as if it was a fuzzer. Okay. Write operation which runs on output to which grabs all inputs within input network and serialize them in the formula. So attempt to import chain from newly created dump and confirm. That means confirm via Firefly UI that we are looking at equivalent data with different keys having signed. And so let's say write operation which runs on output. So this would say, so build on what we found here. So I'm going to push this up. So I'm going to date it. I think, what time was it when we started? I don't know what time it will say. I'm not sure what day it will say. We'll just put the quest for a peer DID layer 3A and 3D compliant lib. Okay, so then basically we went far on that quest. We got all the way to the point where there's like some really robust solutions we don't have to build upon. So yeah. Now I understand what Daniel meant on Twitter when he said that the DIDs are really the core. When he said that they were really the core, he wasn't kidding. That the rest of the stuff, where we need to go as far as abstraction layer wise to actually start using this stuff is pretty far out. The ecosystem seems pretty mature. This is great. So I wish I could just dump every URL that was open, copy paste every open URL. That would be so helpful. Okay. So found out we're going to use this code to try to save /load from DID based blockchain that will spin up using Firefly or Aries, hopefully. Okay, and then we'll put a link to the So we'll put a link here and then we'll backref. So always backref. So where's this good log? Right, just for your own convenience, always backref. So we can say https github.com/intel/df/commits or tree, and then that's going to take us to this, and I think we could probably okay, so this is the branch. Oh, I named it peer ID, didn't I? Oh well. Okay, great. So we're going to reference this here now. and that way each one is linked to the other. So if we go in the if we go here, now we have the link back in the comment. Okay, so I think it's probably time for me to call it, but we'll try this Firefly stuff tomorrow. So this is pretty sweet. So then we can move on. Once we've confirmed that we can save and load from the Firefly stuff, we're hooked into the entire ecosystem of the Hyperledger um, uh, blockchain stuff. We can, leverage that infrastructure, that highway of data, and we can build our proxy services to get, and our proxy services for basically any operation you write can now get data in or take it out of the blockchain just like that. If we can get this working, what we just wrote up. And that's going to allow us, to basically have the blockchain as this the merge command that we have between sources. The blockchain is going to be sort of our transparent like interface because it can operate as this flexible graph database. So we'll have this lossless translation between sources. Okay, great, because we can encode as much metadata as we need. All right, so thank you for watching, if you did watch, and goodbye.